Let us consider the problem. The impulse response and input to the system. So you can consider LTI system is given as x of t equal to u of t plus 1, h of t equal to u of t minus 2. Determine the output of the system. So that means, so they have given the impulse response. So they are applying x of t, so this signal to the LTI system. So we have to find out the output for this input signal. So let us see the solution. So it is the problem which can be solved by using a convolution integral formula. So that means y of t. So symbolically I can represent convolution integral as x of t star h of t. The formula which is given by minus infinity to infinity. So x of tau h of t minus tau d tau. So that is nothing but my y of t. So now let us sketch the signal. So x of tau. So x of tau, it is u of tau plus 1. So then if I sketch that one, so it looks like this. X of tau. So then I can represent t plus 1. So it is time advanced. So by minus 1. So with respect to tau. So this is a sketch of x of tau. Similarly, we have to sketch h of t minus tau. So prior to that, first if I sketch h of tau, so look at is u of t minus 2, it is delayed by 2. So then if I sketch h of minus tau, so then what I am getting here, h of minus tau, so it looks like this. So h of minus tau, it looks like this. H of minus tau. So now, so it looks like this. So it is at minus 2, 0 with respect to tau. If I draw h of tau, it is u of t minus 2. Tau minus 2 means at 2 it will start. So now the mirror image of that, so that is nothing but my h of minus tau. So now we can easily sketch one more signal. So the required one, that is h of t minus tau. So h of t minus tau. So if I draw that one, h of t minus tau, so you can easily represent. So anywhere you can represent here. So I already told. So if you at all you are not drawing this y-axis also, it's okay. So based on this t value, whether it is positive or negative, so that you are getting here. Suppose, so you can sketch like this, h of t minus tau. Like this also you can sketch. So I am considering here this point, say t minus 2. So t minus 2. So and its amplitude value is everywhere 1 because it is a unit step function. Okay. So now we have to look here x of tau and h of t minus tau. So the methodology we are using, so where the signals are overlapping, so then I am getting output y of t. If the signals are not overlapping, so at that range, so then I am getting y of t equal to 0. So let us look this signal. If this h of t minus tau, so this signal, if this is t minus 2, which is less than minus 1, so then there is no overlap. So hence I am calling it as a, so output y of t equal to 0. So that becomes my case number 1. So So let us write that one. So case number 1, for t minus 2 less than minus 1. So or it is also written as, if I bring this minus to this side, this implies, then it becomes plus 2. Plus 2 minus 1 is 1. That means t less than 1. So this condition, So then there is no overlap. There is no overlap between x of tau and h of t minus tau. Hence, y of t equal to 0. So next I will consider case number 2 for, look at here. So now I am taking here this t minus 2 greater than or equal to minus 1. So that means somewhere t minus 2 is here, means the overlapping range is from minus 1 to t minus 2. Where this t minus 2 is placed, that means I am taking it is greater than or equal to minus 1, means let us look at here. If I place this t minus 2 here greater than, I have taken this much, means so the overlapping will start from minus 1 to t minus 2. So that means case number 2, for t minus 2 greater than or equal to minus 1, so that is nothing but, so t is greater than or equal to 1. So then there is overlap between x of tau and h of t minus tau, from minus 1 to t minus 2. So therefore y of t equal to integration. So now the integration range is from minus 1 to t minus 2. So x of tau value is unit step function 1, h of t minus tau is also unit step function, again its value is 1 only. So d tau, which is equal to, so t minus 2, so 1 with respect to tau, integration is tau, so and the limit range is minus 1 to t minus 2, so which becomes t minus 2 minus of minus 1, which is equal to, so plus 1 minus 2, it becomes t minus 1. So therefore my y of t signal becomes t minus 1. So those are the two cases. So we have considered. So also we can sketch here the output signal y of t. So if I sketch output signal y of t, how it looks like here, look at here, y of t. So if it is t less than 1, so its value is 0. So I can mark here, let us take 1, 2, 3, 4, 5. So enough it is. So now it is till 1 less than 1, its value is 0. So if I put here t value as 1 here, look at it, 1 minus 1 equal to 0, so greater than or equal to. So then after that, if it is t value is 2, so now you can mark here like this, I'll get, so if it is 3, then I should get t. So that means, so I am getting the ramp function like this, the time shifted ramp function. So we are getting like this. So this is my y of t. So we have obtained the output y of t for an input signal, this one. That means knowing this impulse response, we have found out the output y of